everyone. Hope all of you are doing well. In the last two videos we were discussing the previous question papers from the chapter units and measurements. Today also we can continue with the same. If you have not watched part 1 and 2, please watch it before going ahead with part 3. Now we can move to the first question. The question is asked in the year March 2014. Okay. This is a 3-mark question and there are 3 questions in this. The first question is, the centripetal force on a body in a circular motion is given by F is equal to mv square by r. Write the dimension of force. The second question is, using the above formula, write an equation to find percentage error in centripetal force. The third question, what is the number of significant figures in 0.050 Newton? So all these questions carries 1 mark. Are you ready to answer the questions? Okay, now we can answer it one by one. What was the first question? Yes, it is to write the dimension of force. Okay, here one equation is given, that is F is equal to mv square by r. And we know that the dimension of force will be always the same, right? That is, force is equal to mass into acceleration. So what is the dimension of force? That is, mass is m and acceleration means that is velocity by time. So that will be L t raised to minus 1 by t, right? So that will be m L t raised to minus 2. So that is actually the dimension of force. Okay. If you don't remember that thing, you can find it from this equation also. That is mv square by r is given here. So from this equation, how we can calculate the dimension? Here we have m. What is the dimension of m? That is m itself, right? What is v? V is the velocity, right? So what will come? L by t, right? So that will be L t raised to minus 1. And what about r? R is also a distance, right? So that will be m L square t raised to minus 2 by L, isn't it? So what we will get? That one L and L will get cancelled. So what will be remaining? Yes, that is m L t raised to minus 2. So that we will get the same answer. So any one method can be used to calculate the dimension of force. Is it clear? Can we move to the second question? Okay. What was the second question? Using the formula, we have to write the equation to find the percentage error in the centripetal force. So the centripetal force is F is equal to mv square by r. Right. So how we will calculate the percentage error? Yes, we know that percentage error is equal to relative error into 100. Relative error is delta f by f. That is the relative error into 100 will give the percentage error in force. So how we can calculate? So that will be delta f by f into 100 is equal to each term we have to find, right? So what will be the relative error in mass? That will be delta m by m. Right. So into 100 is the percentage error. So delta m by m into 100 plus we have v square. So how we can write? That will be 2 into delta v by v into 100 plus delta r by r into 100. That is delta f by f into 100 is equal to delta m by m into 100 plus 2 into delta v by v into 100 plus delta r by r into 100. So that is the equation for finding the percentage error in the case of centripetal force. Okay. Is it clear? Can we move to the next question? Okay. The question is, what is the number of significant figures in 0.050 Newton? Okay. How we can find the significant figures in this case? This number is less than 1, right? So what is the rule of finding the significant figures in this case? We have studied that if the number is less than 1, zeros on the right of the decimal point but to the left of a non-zero digit are not significant, isn't it? So what will come here? Here 0.050 is here. So first 0.05 means here this 0 just before 5 is not significant, because it is right of the decimal but left of a non-zero digit. This is not significant. So how many numbers will be there? Yes, 2 decimal points will be there. So the answer is 2. Is it clear? Now we can move to the next question. This question is asked in the year 2013 SAY examination. The question is, significant figures determine the accuracy of the measurement of a physical quantity. The first question is, the radius of a sphere is given by r is equal to 1.03 meter. How many significant figures are there in it? So this is a 1 mark question. And the second question is, if the percentage error in calculating the radius of the sphere is 2%, what will be the percentage error in calculating the volume? This is also a 1 mark question. Are you ready to answer the question? Okay. Then the first question is, the radius of a sphere is given as r is equal to 1.03 meter, right? So we have to find the significant figure. What will be the significant figure in 1.03? Yes, we know that all the zeros in between non-zero digits will be significant. So this 0 is 1.03 means this 0 is also significant because this is coming in between non-zero digits, right? So how many significant figures are there? Yes, that is 3. Is it clear? Yes, now we can move to the second question, right? What was the second question? Here we have the percentage error in the radius of the sphere, that is 2%. Then we have to calculate the percentage error in volume. So that what is the volume of the sphere? Yes, that is V is equal to 4 by 3 pi r cube. Okay, and we know that the percentage error in radius, right? So how we can write the percentage error in volume? That will be equal to delta V by V into 100. That is relative error into 100. Isn't it? Then how we can write? Delta V by V into 100 will be equal to this 4 by 3 means that is a constant and pi is also a constant, right? So is there any that is delta V by V into 100 is the LHS, right? What about the RHS? Here we have 4 by 3 pi into r cube. What about 4 by 3? That is a constant, right? So is there any error in it? No. So we can avoid that thing. Then what about pi? Pi is also a constant. So that 4 by 3 into pi has no role in it, that we can avoid. Then what is remaining here? That is r cube. What about r cube? R cube can be written as 3 into delta r by r. So that into 100, right? So that will be the relative error into 100. So that we will get the percentage error. Now we can substitute the values. Okay. So what will come? 3 into delta r by r into 100 is the percentage error in radius, right? That value is 2. So what will come? 3 into 2%. That will be 6%. Okay, so the answer is 6%. Is it clear? Can we move to the next question? Okay, this question is also asked in the year 2013 SAY examination. Okay, this is a 1 mark question. The question is, the correctness of an equation is checked using the principle of homogeneity. For an equation, x is equal to a plus bt plus ct square, where x is in meter and t in second, what will be the dimension of b? Okay. Here we have to find the dimension of b by using the homogeneity principle. The equation is given as x is equal to a plus bt plus ct square. If you know the principle of homogeneity, it is very easy to solve the question, right? So what is the principle of homogeneity? Yes, according to principle of homogeneity, the dimension of all the terms on the two sides of the equations should be the same, right? So how we can write? Here we have to calculate the dimension of b, right? So only that term we can consider, right? So that bt will be equal to the LHS. So what is coming in LHS? That is x. So that is x is equal to bt. Also it is given that the value of x is measured in meter. That means x is a length and t is in seconds, means t is time, right? So how we can find b? If x is equal to bt, what will be b? b will be x by t, right? So how we can write the dimension? Dimension of x will be L and dimension of t will be t, right? T, isn't it? So how we can write that b will be equal to L by t. So that is equal to L t raised to minus 1. So that is the answer. The dimension of b will be L t raised to minus 1. Now we have completed the previous question papers from the year 2013 SAE examination. That is, only these two questions were asked for SAE examination, and the rest of the question we can discuss in the next video. Can we conclude now? If you like my video, please don't forget to subscribe. Thanks for watching.